Hey y'all, it's Mr. Kyle Myers Mathematics, and let's just jump into it here. We've got another series problem, and this time we're starting at 2, and that's probably because even though we normally start at either 0 or 1, if we had started at 0, or let's say 1 actually, if we had started at 1, then we take the square root of 1, and then minus 1, and then get 0, and then we'd be dividing by 0, and that's no bueno. So that's probably why we're starting this series at 2. But normally series will start at 0 or 1 or whatever. The start of the series doesn't matter that much, practically speaking. But if you were wondering, that's probably why they're starting at 2. So this one is gonna diverge. All right, I'm gonna just spoil it right at the beginning here. It's gonna diverge, and that's because the square root of n has a power of 1/2, so it has a degree of 1/2. The numerator has a degree of 0. P series says that the degree of the numerator has to be more than 1 greater than the degree of the numerator. Let me say that again. The degree of the denominator has to be more than 1 greater than the degree of the numerator. That's sort of like an altered P series. That's not what the actual textbook definition says, so don't quote me on that. But that is a better, in my opinion, better definition of P series. In fact, I'm working on a name for it. It's called the K series. K for Kyle. So take that as it is. But that's essentially what I'll do at the beginning of these videos. Is I'll tell you whether it converges or diverges right off the bat using my own series that I've formulated over the years. So let's go ahead and do this one by the book, though, just so that your teacher doesn't get mad, right? So what we're going to do is we're going to rip off the minus 1, and that way it's just the 1 over the square root of n. So this whole thing right here is going to be a sub n. It doesn't matter that much which one is A and which one is B. I might want to switch them, I might not. We'll see. But if I take off the minus 1, and I'm not good at multitasking, sorry. Let me move this over, actually. Whoop, 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 whoop. We're going to erase that. So we're going to say that this is just this, and still didn't get rid of all that. There we go. This is going to be, if I rewrite this as a power in the denominator, it'd be the 1/2 power, yeah? Yeah, you guys can just barely see that. So this is what I want to do because then I can use P series on that. I can say that that diverges because of P series. We're going to call this B, actually. This is going to be B sub n. B sub n is equal to all of this. So then we know that from n equals 2 to infinity of B sub n, we know this is going to diverge by the P series. By the P series. Fancy. So we now know that it's going to diverge, and what we want to do is we want to make sure that it's tied to A. A is actually a stronger series, so if the weaker series can diverge, and I know A is stronger, by the way, because I'm minusing 1 in the denominator. If you make the denominator smaller, it makes the number bigger. So think about it. Like, which is bigger, 1/4 or 1/3? 1/3 is a bigger fraction because it has a smaller denominator. So if you make the denominator smaller, you're going to have a bigger number. So the A sub n is going to be a larger series. It's the larger of the two. A is bigger than B. So if the series that's smaller diverges, then the larger one will have to diverge as well. And that's just the comparison test. The direct comparison test, I'm not a huge fan of it, but essentially it works like this. Think of if you have, and I'll do a little illustration for you here. So think of you are, let's say you have an older brother, and your older brother is much stronger than you. They do steroids. They're like a TikTok influencer. They always do all of their videos without a shirt on, bulging muscles, and they have they advertise all kinds of things and get paid from the ad revenue. So let's say that they have diverge means to lift the box in this case, right? So if I can lift the box, then I'm diverging it away, right? I'm diverging it away. So diverging is pulling the box away. Right? So if I'm able to pull the box up, then I'm diverging it. Well, if you, and you're the weaker one. Your brother is stronger. This is you and your weak little skinny arms. All right. So this is you. If you can pick up this box, if you can diverge away this box, then your beefy older brother, right? So these are his forearms. These are his biceps, right? And he doesn't even have, he hardly even has I'm not even going to be able to fit his legs in here because his torso is so huge. So he's giant legs, torso, and he doesn't even need his other arm. He's just making a muscle with his other arm because he's just huge. He's just jacked. You can't even see his head. That's Yeah, so that's him. He's just all muscle. He turned himself into a cloud, okay? So if you can pick up the box, then your beefy older brother can pick up the box too. Right? Lightweight. They can pick it up. If you can pick it up, they can pick it up. Make sense? So if the weaker function can diverge, then the stronger function can too. Right? And that's actually what's happening here. Right? So the A function is stronger than the B function. The B function diverges, so the A function will too. So we're actually pretty much already done doing this by the book, but I'm just explaining it because one, I don't really like the direct comparison test, which is what we're doing here. So I'm probably only going to do one video on this. This is probably going to be that video because I'd much rather do the limit comparison test. It makes way more sense in my opinion. However, it gives me a time to work on my abilities to draw things, and I'm such a great artist that I would bless you with my talents here. So let's say we have a much larger box. This is 100 tons. This is a 100-ton box. I have no idea what's in it. Um, secrets to life, the universe, and everything, I guess. But even though your older brother is completely jacked, they cannot. Now they're using two hands because this is like ridiculous. And even with their bulging biceps here, bulging biceps. They can't even fit their legs in here because they're so huge. They're so massive. And actually, they're like on the ground trying to lift it. They're in a full squat position. Maybe that's what's actually happening. So there's their head. You can see their head now, and then there's their shoulders, and then their legs are down here somewhere. Trust me. Okay. So this is they're trying to pick it up, and they cannot pick that box up. All right. That's a heavy box, and they cannot lift that box. Are you, with your little noodle arms, are you going to have any chance at lifting that box? Absolutely not. If they can't lift that box, if your jacked older brother cannot lift that box, you have no chance. You have no chance. You got noodles, okay? You like cake too much, if we're all being honest, okay? Cake tastes really good. What can I say? Your brother eats nothing but chicken and broccoli. But I mean, I get it. Cake tastes good. So you can't pick it up either. Well, this would be converge. The box is going to converge. It's going to converge in the spot that it's at. That's all I got. It's going to stay. It's going to stay there. It's going to stay converged to the spot that it's at. Okay? So if your beefy brother, if the stronger function converges, then you converge too. All right? Now, the weaker function diverged, so the stronger one will too. And that's pretty much it. That's actually it. Now, in order to use divergent, the direct comparison test, technically both series have to be greater than or equal to 0, and one series has to always be bigger than the other for all values of n. Okay, so if we wanted to do it really, really, really by the book, you'd have to prove that one series is always bigger than the other. I'm not here to get that nitpicky. If your teacher is that nitpicky, then we probably need to meet in person and do some like tutoring sessions and stuff because your teacher's crazy and they're trying to kill you. Okay, this is for all you people out there with normal professors. This is what they're looking for. Normal professors are looking for this. So first of all, we're going to say it diverges by the p series, and then we're going to say that therefore the A series. Can you guys see that? Yeah, you can. Okay. The A series, so from n equals 2 to infinity of a sub n, which we already established, is 1 over the square root of n minus 1. Therefore, this converges also, sorry, diverges. This whole time I've been saying it diverges, and then at the very end I just had a brain fart. Okay, sorry. Diverges also by the direct comparison test, which I'm actually kind of running out of space here, so I'm actually just going to call it by its other name, the comparison test. Sometimes it's called the comparison test. Comparison test. Cool beans? Okay, so that's pretty much it. That is more or less by the book. Again, if your teacher's looking for something really, really crazy, by the way, don't put the illustration in your explanation for why the comparison test works. You would just, in order to show proof for a normal professor, you could just use like a t-chart and just show like values of n that are greater for the a sub n function. Like for instance, if you plug in 2, 1 over the square root of 2 minus 1 would be like 1 over 0.4, which is like 40. And then for b sub n, if you were to plug in 2, it would just be 1 over the square root of 2, which is 1 over 1.4, which is like a little less than 1. So, yeah, and then you could just, try a couple different values, keep going from there, right? You're not counting down, by the way, you're counting up to infinity. So the next value you would try, the next n value would be n equals 3, and 4, and 5, and however many you think your teacher wants to see. Basically, whatever they've been showing you in the notes is what they're going to want to see, more or less. So that's what I would do. But again, if you have a crazy teacher, let me know. You can even shoot me a comment in the comments below. And yeah, so there's going to be some playlists that'll pop up, and one of them will be the calculus playlist. You can check out other videos that are in this series on series. That is a really hard phrase to say. It's really have to enunciate. And then I also have some stuff on my website, the 5 math mistakes everyone makes and how to avoid them, as well as some calculus stuff on there as well. So go check that out. That's Myers Mathematics. You can check that out in the description below. Catch you guys in the next video. Blessings.